catch up. And if you need to check things and go back and see what one of us said or the like, you can do that. So we make those available to you later. So we're recording the session. Okay, just here seeing a comment there that somebody only has the audio working. Okay, so if that's the case, you do have the slides in Moodle and on your memory stick. So that might be your backup plan if you can't get the vision to work. You should be able to follow along the slides that way. Not quite as good, but one of the many backups we have in place. Please jump on the chat or the Q&A if you're also experiencing that issue. But I think others are looking pretty good. And Jamie said he can see the slides, so might be just an issue on that one. Sometimes if you log out and log back in, it can fix things. And we're just going through some admin and logistics and stuff for the next 5 minutes or so. So might be worth trying. Okay, so I think we're recording. Are we recording? Yes, very good. Okay, so my role is really to moderate the session, MC the session. I also will present a couple of the topics that I have a particular interest in or have been sort of specializing in a little bit for a while. And I'm your port of contact as you have any challenges throughout the course, or you want to know how to upload your assignment, or you can't upload your assignment and you want to email it through instead, or the like. So my contact details are down here. So please make sure you keep in contact if anything pops up. The way that you communicate and chat with us and in these sessions are using the chat function or the Q&A function, I should say. Now, a lot of Transport for New South Wales people seem to have an issue with the chat not appearing, but the Q&A seems to be there. So feel free to use the Q&A and you ask your questions as we tick along anytime throughout, and we'll get to answering those. We just use the webinar version of Zoom as a bit of it makes it a little bit easier to manage in terms of unmuting, like people having dogs barking in the background, or all those usual challenges of people leaving themselves off mute. So the webinar version just gives us the control to be able to allow you to speak or not. But if you want to raise your hand, you can raise your hand, and that gives us an indication that you would like to actually say something, have a bit of dialogue with Jamie or myself or one of the other presenters. So do feel free to do that. We encourage that, especially if we're trying to delve into some of the specifics of something to do with road safety barriers. You do have dial-in options if everything fails, and you can text me or get in contact with me if things are going really bad. So the course presenters, we've got Jamie Robinson, as I mentioned, technical lead at Safe System Solutions, and has been heavily involved in road safety barrier design, auditing, and the like for well over a decade, maybe 15 years even. Used to be the technical lead of traffic engineering and design at the Victorian Road Authority, VicRoads. Before joining Safe System Solutions, and has done quite a bit of looking and reviewing and making technical assessments of barriers in New South Wales as well. Evan Coulson in the middle there. Evan is from the Department of Transport in Victoria, but is on ASBAP, the Austroad Safety Barrier Assessment Panel. So is one of those people who is spending a huge amount of times with understanding how road safety barriers are going to be rolling out across Australia and New Zealand, products, design, different systems and the like. So Evan will join us next week to talk about, tomorrow to talk about a number of different topics. And myself there, Principal Engineer at Safe System Solutions, and have had a reasonable amount of exposure to road safety barriers, mainly in the auditing road safety auditing, and a little bit of sort of being involved in design projects. But Jamie and Evan are your absolute barrier fanatics and barrier experts, and I'll just be making sure the ship continues to roll along. Your learning management system is Moodle, and hopefully all of you have managed to log in and get yourself on there, because that's where we'll be. You'll have to do some quizzes, sort of little tests at the end of each session. It's where you'll upload your assignment that you'll do after tomorrow's session. It's where you can introduce yourself and see who else is in the class. So get in there. It is great if you introduce yourself, a little photo or video or something to just show others who you are. I'm sure a lot of you know each other, but it's nice to see some faces from some other regions. If you have trouble with that, let me know getting into Moodle, and I'll make sure I help you out there. Now, one of the ways that we try to keep you engaged, make sure you're listening, concentrating, and watching the slides. I know it's very tempting to do your emails or your roundabout design or barrier design on the side, but we have Wally the Wombat. And Wally the Wombat appears randomly on slides, and your job is to count the number of times Wally the Wombat appears on the slides. And it'll be one of your quiz questions at the end of session quiz. How many times did Wally appear? Now that's a Wally the Wombat sign, Wally the Wombat warning sign. And don't include that one. Your Wally count is 0 at the moment, but have a little scrap of paper or something just to keep track of how many Wallies you see. We do give a little bit of tolerance either side in the quiz answer in case you miss one. But yeah, keep an eye out for Wally the Wombat. So we do have a benchmark requirement on the successful completion of this course. We want people to attend 3 of the 4 live webinars, so you can ask your questions and interact and delve into different issues if you need to. And then we want you to view the other one that you haven't attended. We need you to complete all the set tasks. So they're the quizzes and the assignment that we have. And there's no site visit for this course, but some of our other courses, we actually send you out to sites very close to your workplace or home. And we need you to achieve an 80% pass mark on the quizzes and the assignment. Now, don't get too concerned about that because you have up to 3 attempts. And if you do your first attempt and you really are struggling, that's when we want you to get in contact with us, and we will do some one-on-one coaching with you and help you understand the fundamentals. But our aim is to just ensure that everybody gets up to that benchmark. The content, there's nothing in there in the quizzes or the assignments really that hasn't been explained to you in the session, so you can always go back to the notes or the recording to find those things out. But it's just a way for us to ensure that if we hand a successful completion certificate to you, you have a level of competency in the fundamentals of road safety barriers, which is what we're going to be going through over this week. I want to acknowledge the traditional owners of the many lands that we're running this training and pay my respects to the elders past, present and emerging. And there's quite a few lands that we're running the training on across New South Wales. And Jamie and I are both based in Victoria and used to spend quite a bit of time in New South Wales, but have struggled a little bit in 2020 to spend too much time with you. I want to thank the Centre for Road Safety of Transport for New South Wales for their initiative to put on these courses, and they have an absolute determination to upskill the industry in appropriate and correct use of road safety barriers, because they are very aware of the wonderful safety benefits we can gain from the correct use of road safety barriers. So thanks to the centre there for the support of this training and other training. So this course that we're doing is, before COVID, it was there was a 3-day course that we would run live with you, and it was the first day was fundamentals, which is what we are going to be covering over these modules, and then the last 2 days are all about design and getting out on site and practicing your design of barriers and making those on-site decisions. So we've taken we've carved off that day 1, the fundamentals, and we've put it into these modules, our modules. So we're going to run through that, and then hopefully once the world gets back a little bit more normal, we can come and do those last days, or last day and a half with you in your offices, and get you out on site and do a bit of the on-site challenges that you find. I think that's about it in terms of the logistics, the running of the course and the like, but please pop in any questions into the Q&A if you have any now about how things are going to run. Otherwise, I'll just give a bit of a general overview of road safety in New South Wales and the way barriers will play a role in achieving some safety outcomes. Okay, I'll take that people are pretty comfortable. Most people are able to see and hear things. You have that Q&A as your go-to, or the chat to ask your questions as we go. Please do that. It may be a little bit of time before we answer it, but we'll look for points where we can ask questions, answer questions, and we'll have a bit of that dialogue. Certainly when Jamie's presenting, I'll be behind the scenes monitoring the Q&A and then feeding questions to Jamie. We may pop in some little spot quizzes and those sorts of things. And of course, some of you who have come along to different technical training courses run by Safe System Solutions know we do like to give out a prize. And the way that works basically is that as we go along, if there's any prize-worthy questions, maybe first to answer correctly or something like that, we just take a note of who wins the prize. And when you get posted your certificate, there might be a little chocolate bar or something in there as an extra prize. So we'll keep a tally of that as we go. The other thing we do is before the start of each session, we do a little bit of trivia, just random trivia. Could be road safety related, could be other, and again, a chance to win a few prizes. But that's an incentive for you to log in 3 or 4 minutes early, and we will ask a few trivia questions, and then we will hit the ground running right on the hour with the content of the course. So log in a bit early tomorrow for another chance to win a prize. But let me go and give you a sort of general introduction overview. I'm not going to spend long on this because I definitely know that some of the names I recognise on the list there are very well versed in road safety and what's going on in New South Wales and the different challenges that you face and the scale of the issues we face. But I will do this as a little bit of an introduction. So there's just a graph representing fatality trends in New South Wales since 1996. It is so a general downward trend, which is pleasing to see. It does start to flatten out a little bit in the later years. So that's the fatalities, and we're seeing numbers, ranging in there 300 up to sort of 700 there, so 350-ish, dipping down there. But it's a pretty big number. You have a large population, but still these numbers are quite large. Serious injuries are often something that people don't quite have front of mind when they're thinking about road safety. Fatalities get the headlines and are reported. The serious injuries are often the ones that last a lifetime, lifelong care, acquired brain injuries, quadriplegia, paraplegia, So quite a spectrum of what can be in the serious injuries. The serious injury definitions are really admitted to hospital, and so that means that you can have some lesser severity injuries where people recover, maybe some physiotherapy, but they are able to lead a normal, healthy life. But there are quite some serious, some very serious incidents within this. There's categorizations of serious injury, so you can go into more detail, and the Centre for Road Safety certainly does that sort of work to gather an understanding of that. But the magnitude we're talking here, 4, 5, 6, up, 6,000, 5,000, 5,500, huge numbers of serious injury, which sort of bubbles away under the surface of those fatalities. And that is a major health a crisis really going on in New South Wales. And it's a challenge because it's something that has been ticking away for all of our lives, really. And the fatalities and serious injuries just keep happening, run of the mill. And so getting huge traction to change that can be very challenging. But there is a good bit of work going on. Now you see there the serious injury trend starting to come down, which is very promising. And we hope to continue that to go down. If you just sort of break things up a little bit by metropolitan or country or regional, I'm just using some exact terminology that came out of a Transport for New South Wales report. So you have a look here, we're doing fatal and serious injury combined, and we've got the crash types. And so you see there off path or out of control on straight there. We've got the regional, country, and metro a little bit less. You see there off path or out of control on curve, that being the largest there in country area and the largest of any of these bars. And then we've got pedestrians, metropolitan area, obviously a large segment there, and not as many in country areas, but still certainly there. Rear ends coming in, again, metro more than the country areas. And then we've got some intersections, and again, metro areas are producing more crashes there, more fatal serious injury crashes, as you might expect. Other opposing directions, another intersection category. And then we've got head-on, not overtaking. So there's not an intentional overtaking maneuver in the head-on, but the head-on crash has occurred. So that's the sort of overall trend in fatal and serious injury crashes. If I just use the fatals as an indicator of severity, so yes, we had serious injuries and fatalities, but the most serious and the most damaging being the fatalities as an indicator, but this is probably a good indicator also of your highest levels of serious injuries of the serious injury category. You see there that country New South Wales or regional New South Wales starts to pop out as a dominant area of this. Now, there are a number of factors that mean that we see all of a sudden that country pops out very high in these categories. What would that be? The first person to put probably the most dominant factor in this into the Q&A can win a prize. So, Wade has jumped in there very quickly with speed, and speed is absolutely the dominant factor in terms of the severity of crashes. Now, there are many other factors, and I noticed fatigue popped in there as one. So certainly, yes, people are having long distances and they're getting tired and they're leaving the road, and those are sort of causal factors, absolutely. The speed creates the severity of these crashes, and why we see the fatal end popping out higher, and the higher level serious injuries as well. And you see there that we're going off path on curve, head on, not overtaking, sort of jumps out significantly, and off path or out of control on straights jumping out. Now, interestingly, I sort of categorize all of these together a lot of the time as a lane departure crash. So somebody has left their lane for one reason or another. And it could be, yes, they fell asleep. It could be they were distracted. It could be they were avoiding a kangaroo that jumped out. So all sorts of possible reasons there. One thing I suppose I want to dispel as a bit of a myth is this head-on, and in brackets intentionally put not overtaking, because people see these head-on crashes and sometimes conjure up an image of an inappropriate overtaking maneuver, not having enough space or time to do that. And we'll see that I actually chucked in down the bottom here those actual incidents in terms of overtaking with an intentional overtaking act, as the police have, determined from their analysis, that has resulted in the death of either the person doing the overtaking, or the passengers, or the other vehicles. So we see they do exist, but they're very small in comparison to the unintentional head-on. Now those unintentional head-ons can be drifting out of the lane into the opposing lane, can be drifting off into the roadside and then overcorrecting and going onto the other side of the road. And there's quite a few sort of mechanics of these crashes that can happen that result in that head-on. So I'm just painting this as a general picture to show, well, first of all, I suppose, the scale of the issue we're dealing with. And these are staggering in terms of thinking about them as people rather than just sort of numbers and graphs. And sort of somewhere in the range of 5,000 people from New South Wales killed or seriously injured. And if you think then the family, the community, and the social impact of that, not just the economic impact of that, which we can get caught up in benefit cost ratio analysis and those sort of things. But this is a major health crisis going on, and we need to really put the hammer down on trying to address this. And there's some pretty exciting stuff happening, and some pretty big funding that has been secured for initiatives that will bring these numbers down. And absolutely the identification of people leaving their lane being a high severity injury crash type has been there. I suppose it's always interesting to break this down by the rest of the world, and I do this very quickly just as interest. And these were some Victorian graphs, so that's why Victoria got highlighted. But New South Wales is in there as well, as you can see. But you can break down sort of your road safety performance in a number of measures: per fatalities per 100,000 population, or per registered vehicle, or per 100 million VKTs, vehicle kilometers traveled. So that would be the exposure, so how much moving around is actually happening. And you see there that the sort of the European, Scandinavian countries sort of dominate across all these forms. We see there Victoria, New South Wales popping in there, and then we sort of go down and the rest of Australia sits below that. But this is the top end of the world. And if we look there, and I just grabbed a few others, you see there it starts to really kick up with the USA is about double in terms of per head of population. The US will always argue that it should be vehicle kilometers traveled because they travel more than anybody else, they say. But even when you cut it down by that, they don't perform that well either. And then you can see here, and I just picked a few of the countries, but the majority of the world sort of sits in this range down, and you see some pretty horrific road safety performances from countries like Thailand and some of the developing or middle income countries. The 4.4 might be a little inaccurate now. I've got to recheck and update that, but probably somebody there can give me a more accurate figure than that these these days in New South Wales. We're dealing with a worldwide health epidemic. It's just been happening so long, and we're so familiar with it that we don't respond to it in the way that we do with something like COVID. Yeah, it's about 3 months ago, the COVID death toll surpassed the that of road fatalities around the world, and so about 1.3 to 1.4 million people killed every year on the world's roads, and somewhere around 10 times that seriously injured, although there's not good data really available on that for most of the world. And it'll happen again next year, and the year after, and the year after, and the year after, and it'll just continue to roll. It's a huge, huge issue, and we've got to look for ways that we can address this, as we've been doing. But certainly in New South Wales, one of the biggest and most violent and most severe crash types that you're seeing on your roads and roadsides are where vehicles leave the road and they hit point source hazards, be that a tree or a power pole. Now these crashes are happening at speeds that are unsurvivable for the occupants of the vehicles, even in the best vehicles that we have available to us. The energy transferred to the occupants of the vehicle when they strike power poles, trees, you cannot survive that. Your body is not designed to survive that, and the vehicle is not strong enough or not designed well enough to protect you at those speeds. And even the head-on crashes, while they are often less severe and more speed, you can crash at higher speeds because of the crumple zones, the airbags, the seat belts. In that frontal impact, we still see quite a large amount of death and serious injury from head-on crashes. Now that picture might be a little misleading in terms of it looks like a very front to front. We often see quite an offset in these crashes, which actually even makes it more severe if you're sort of only hitting half of the vehicle you're head-on crashing with. Interestingly, we do also see quite a number of, especially serious injuries with lane departure rollover crashes. So they have maybe struck something small in the roadside. Maybe they have been yawing, which is where a vehicle starts to slide. So they've maybe tried to get back on the road and they've slid to the side, and their tires have collected some dirt and pushed the dirt around, and they've started to roll. And then again, this is not as severe as that point source tree or power pole strike or the head-on, but we certainly do see quite a bit of especially spinal injury associated with these rollover style crashes. So we've got these cleared areas on the roadside, yet we're still seeing serious injuries occurring. Admittedly, there are quite a few people that will leave their lane into a roadside, and if it's cleared, will recover and they will not be involved in an incident. And so we need to factor these sorts of things into how we go about managing and designing the roadsides. And Jamie's going to delve into that in a lot more detail. Even things like cuttings. So we, in the past, I suppose, used to think of a cutting as almost like a barrier in its own right and ignore it. But we do see vehicles snagging on cuttings, vehicles riding up them and rolling. And again, we see a serious injury and sometimes death presenting itself from cuts. And of course, fill batters the slope and the roll, ability to roll and draw you into other hazards is something of big concern. Now, the New South Wales government is trying to address this through a number of mechanisms, and there's a Road Safety Plan 2021 there, and no coincidence really that there's a barrier on that plan, because barriers are going to make up a huge component of the effort to reduce road trauma in New South Wales. Barriers of different forms put in different places will do that. And the reason for that is that they align very well with the SAFE system, which I'll come back to shortly. There's a couple of key documents, and Jamie's going to take you through these. Austroads has recently released the Guide to Road Design Part 6, Roadside Design, Safety and Barriers. So that's the updated version. It came out very recently. So those are people who have been operating under older versions of that and have got their the way they operate pretty well set, because it hasn't changed that much in quite a long time. There's been some pretty big changes, and so Jamie's going to give you some insights into those. We also have the Manual for Assessing Safety Hardware, or MASH, which is the AASHTO document, which is an American document, but that is about the test protocol for barriers. So what do barriers need to be, how do you test them, and which ones do you accept in terms of passing these tests? So that manual is just a very comprehensive document to tell you exactly how they need to be tested, what weight of vehicle, speeds, angles, what sort of results you need to get, how you need to set the whole thing up, and all of that. Now, this is a new thing within Australia, that we've decided to adopt this test protocol over the one that we were using before. And so you may have heard that with people talking about, well, is that barrier MASH compliant? And this is what it means. Now, Evan tomorrow is going to take you exactly through some of that test protocol and show you what a barrier would need to do to pass that. And that's actually an important thing to understand when you're designing or making barrier choices, to know, well, this is how it was tested. And so this is how we think it might operate, and so we can design or manage accordingly. So a couple of really important documents there, which we'll be running through. So the SAFE system I mentioned, there's many diagrams of the SAFE system out there, but I picked this one. And the SAFE system really is the philosophy that New South Wales is operating under to try to address road trauma. The SAFE system has the aspiration of zero death and serious injury, and says that we should be making choices with that in mind, rather than just accepting, well, you know, a certain amount of death and serious injury as an inevitable cost of transport. The SAFE system challenges that sort of thinking, and says, no, we should be aiming at zero. We acknowledge that's a long way off. And there's huge challenges for us to get there, but we should be aiming at it. The SAFE system acknowledges the vulnerability of the human body and the forces that we can handle before we are killed or seriously injured. And so you noticed earlier I was mentioning side impact with poles, and with trees and those, and the energy involved in that crash is far beyond what we can handle. And we know that because of the human tolerance to physical force. We do know that most vehicles can accommodate leaving the road and side impacting a pole at about between 30 and 40 kilometers per hour, and that's about it in terms of the strike with a power pole or a tree. So the speeds we travel around the road network with point source hazards near the road far exceeds that. So we've got quite a disparity there. We have a shared responsibility. So no longer can we just blame and push blame to individual road users for their errors on the road network, be that falling asleep, speeding, drinking, being distracted, using their phone, whatever it is. We certainly don't condone these activities, and we will work to try to minimize them. But we need to look at our system and why our system lets that happen, and why our system then, when it does happen, lets it result in a death or a serious injury. So we need to start to manage mistakes. And that's a big thing in our industry these days. And it's a big shift, is we are in error management territory. That's how we should be thinking, because the road network is being used by humans it'll be still for a long time. you know, 20, 30, 40 years, still the humans are going to be operating this system. The vehicles are taking more and more of a role, but we're still going to be operating it. And humans make mistakes. And that's our other principle here. People are going to make mistakes. We're going to try to minimize those mistakes, but they're still going to happen. And so what our role is in the design, the management, the operation of a system is to design it so we cater for those mistakes. We design it so we minimize mistakes, and then we cater for them. And so I think it's hopefully becoming fairly obvious in your mind why a road safety barrier is such a highly safe system aligned device, because the barrier doesn't care why. It doesn't matter whether they were fell asleep, they were on their phone, they avoided a kangaroo or whatever it was. The barrier just does its job and dissipates energy along the barrier rather than hitting a solid object or rolling over. And so barriers are probably one of the easiest things to show that they align very well with safe system principles. But the safe system isn't just about the roadside and the road and the infrastructure. We've got the vehicles, we've got the speeds, and we've got the road users. And we also have the way we deal with any incident that happens out there with post-crash care and emergency response and the like. So it's quite it actually is quite a complex interacting system, and most of the diagrams out there are trying to simplify it, and there's lots of other supporting elements to it. But the real takeaway is that barriers are proving to be an amazing road safety infrastructure feature. They align highly with the safe system, which the New South Wales government has committed to and is implementing. There's a huge amount of money being pumped into barrier rollout, and we need to get it right. And so this course is really about setting you the fundamentals of making sure we get the most out of every dollar spent on barriers in terms of life saves and serious injuries prevented, and giving you that base level understanding. Okay, so any questions in that sort of broad general sense before I hand over to Jamie, who is going to actually start to talk to you about when you might decide to choose to implement a barrier or maybe something else, and where you can do those things and what are some of the resources available. So feel free to pop any questions into the Q&A or put your hand up if you would like to actually have a chat. I'll give it a second there. Okay. So I hope you kept your eye out for Wallies in my presentation there, and you've got your count going. I know Jamie's got some in his presentation. So yes, keep going there. As Jamie pulls up his slides, I'll just explain that, yes, you're going to have a quiz at the end of this in Schoology. Sorry, not Schoology, in Moodle. Moodle's the one we're using for this course. And you just go in as 10 questions. One will be how many Wallies did you see in the session, and then the other 9 will be on the content that we're covering. So I'll be in the background monitoring the Q&A. Please type your questions in or comments, and feel free to put your hand up. And otherwise, over to you, Jamie.
Thanks, Ken, and morning, everyone. So before we get into barrier design and selection and all of those things, we want to take a step back and think about what constitutes a hazard on our roadside. Now, there's been a bit of change in this space with the release recently of the updated Part 6 Guide to Road Design. There it is. The first few sections of this document were updated significantly. So those were the sections that deal with risk assessment and hazard identification. The remaining sections around barrier design and the like are largely unchanged. Now, each jurisdiction generally has a supplement to the Austroads guides. RMS has one to the previous version of the guide, which was a fairly brief document, which said basically that you use clear zone principle and adopt the angle of departure method for barrier design and a couple of other things. I noticed that as of today, the RMS website says that Transport for New South Wales has not adopted the new Part 6, but I expect that that will happen very shortly, and that there will be a significant update to the supplement to that guide. So stay tuned for that, and bear in mind that the supplement does take precedence over the Austroads guide. There's also the Guide to Road Safety Part 9 around roadside hazard management. Now that's quite an outdated document dating back to 2007 or 8, but it is a useful resource when it comes to looking at hazards in the roadside. So the updated guide really has changed things up a bit when it comes to assessing hazards, and it's hopefully making it easier for practitioners and a little less subjective than was previously the case. So it's grouped hazards into a few different categories. The most significant of those hazards fall into the significant hazards category. Now, hazards are grouped based on what's referred to as a trauma index. So these are the ones with the highest trauma indices, and they have a trauma index basically equivalent to that of striking a tree in the roadside. So significant hazards include trees and other fixed objects that are rigid and will bring a vehicle to an abrupt stop, utility poles, of course, signal poles, rigid lighting poles and the like. It gives some criteria around batters, which are sort of typically subjective to assess in terms of their risk. So some guidance around fill batter, heights and slopes, and also for cut batters. Watercourses of a sufficient depth to submerge a vehicle and therefore create a drowning risk as well. Drainage structures appear in the significant hazards list. So these are the worst hazards that we encounter on our roadsides. Now, bear in mind that the hazard presented by these things is often dependent largely on the impact speed and also the angle. A vehicle impacting head-on is less likely to result in a serious outcome in terms of injury to the vehicle occupants to a side-on impact, because all of that safety gear, or the majority of it, is built into the front of a vehicle. Speeds as well. Any impact with one of these hazards at high speed certainly is going to result in a serious or fatal outcome. At low speeds, many of these will not, but hazards such as high vertical drops, a cliff for instance, will create that serious crash potential regardless of the speed of the vehicle going over. Now, the other thing to note is that this list largely relates to the occupants of cars, to passenger vehicles. Motorcycle riders might, a significant risk might be presented by lesser hazards than you see on this list to motorcycle riders. Occupants of heavy vehicles, some of these hazards may not be a significant hazard to those due to the more rigid construction of the vehicle. There's the number one killer on our roadsides, trees, and it's particularly the case that we see these fatal and serious outcomes where there's a side-on impact at speeds as little as 30 to 40 k's per hour, as Ken mentioned. And some studies have shown that on our roadsides, something in the order of 85 or 90% of crashes, serious and fatal crashes, occur when a vehicle strikes a rigid object. So there's 10 or 15% left over, which are your rollover type crashes and perhaps a really violent yaw event. But most of the time we're hitting a rigid object. And most of the time, something like 2/3 of the time, that object is a tree or a utility pole. Now we have a little definition for what constitutes a hazard when we're dealing with trees, and anything greater than 100 mil in diameter is typically considered non-frangible and therefore a hazard. And that would apply to any timber, pole or object in the roadside, I would suggest. they can be quite subjective to assess. And I like to show this photo because it's of a project that I was involved in not that long ago, where this species of tree was identified as frangible or non-hazardous, and the decision was made not to shield them with safety barriers. Now, to my uneducated eye, when it comes to trees, they look to be a hazard. There were lots of trunks going on there. I thought greater than 100 mil. But the decision was made not to shield them. This road has since been treated only a short number of years after that initial project. It's been retrofitted with continuous barriers, which have obviously addressed the risk presented by the trees, but also cross carriageway crashes. This is a divided highway, and rollover events and impacts with any other objects that might be in the roadside there. So the philosophy really has changed from shielding isolated hazards that were assessed and considered as a significant hazard to shielding the entire roadside, where we're, especially where we're in high-speed environments. Utility poles, basically identical to a tree in terms of the risks they present to errant motorists. And they're often located in some of the worst spots, the most difficult spots to treat them. Now, we all know how expensive it is to relocate power, and the desirable solution might be to relocate our underground, but that rarely happens. And even if it does, there might be some residual risk in the roadside related to other hazards or rollover risk. So it usually comes down to installing barriers to shield utility poles. Where they're located close to driveways and side roads, as you can see here, it's often particularly difficult to do that. And you can see an attempt has been made to install a succession of short safety barriers to shield some of these poles. You can also see some crash cushions, some raptor cushions wrapped around some poles that were not able to be shielded adequately. Now, these systems are pretty much a last resort. They do provide some protection to poles in a 100 km/h environment. They're not enough, but it is often the case that you see them installed on hazards where nothing else basically can be done. For some reason, these poles in the foreground have not been treated. I'm not sure why. Perhaps there was a sight distance concern with people coming out of the side road. Who knows? This looks very much like a utility pole. It's actually a rigid light pole. I'm not sure which went in first, the light pole or the barrier, but I would argue that putting that barrier in as it has been has increased the risk presented by that pole. The vehicle impacting the barrier upstream of the pole is going to be directed into the pole. We also can't be sure of the way that vehicle is going to engage with the barrier and come to a stop when it strikes the pole and the barrier. So we should be locating any such roadside furniture behind barriers and well clear of barriers so that they allow the barrier to perform freely. Here we have a cantilevered sign support. Now, this one was designed based on clear zone thinking, and the column would have been located outside a 9 or 11 or even 15, perhaps not that much, but a significant clear zone. That was the way that we used to do things. This is on a freeway near Melbourne. On another freeway near Melbourne, some interesting things happened when some of these structures were located a particularly long way from the roadside and with long outreaches. They started to topple over towards the road, which created a lot of issues. And we are now locating these closer than ever, perhaps from the roadside, because we've gone away from that clear zone thinking and we're shielding all of these things with barriers. All of these instances have been retrofitted with barriers to shield these structures. So we have a cantilever there and a gantry here. which obviously has been shielded with a barrier and nonetheless been struck by a large vehicle. That barrier is a wire rope, obviously. It's not one that would have been expected to contain a large vehicle. Going forward, we're seeing a lot, we're seeing high containment barriers installed about these pieces of infrastructure to prevent, in particular, the situation where a truck strikes them and there's a potential for a secondary event where the structure falls over the roadway and leads to further collisions. So you would expect to see perhaps a thri-beam barrier or a concrete barrier installed at a structure like this, depending on the number of heavy vehicles, the volumes, the risk that's been assessed for that particular location. There's a range of drainage structures along our roadsides that present a risk to errant motorists. We often have culverts at driveways and side roads that are located parallel to the road. The head walls that are installed on these culverts present significant hazards to motorists. They're located typically in table drains, as you can see here, which are likely to capture and direct that vehicle towards the structure. The easy fix here would be to replace that concrete end wall with a drivable type and eliminate the hazard rather than install a barrier, or perhaps install a barrier as well to address other hazards. Within a median, we have some head walls and associated drops that might be a hazard to an errant vehicle. You can see on one side of the road, a barrier has been installed. We can install a barrier on the other side of the road to address that risk. Other options might include to pipe between those head walls and backfill to eliminate that hazard, perhaps install a grated pit and make the whole area drivable. Small structures such as this one can be quite subjective to assess in terms of the risk they present. The drop here is not great. It's probably less, well, it is less than that 2 metres that we saw in that list of significant hazards. The decision on this project was to install a barrier on this structure and for some distance either side to shield the non-drivable batters. Where we're dealing with structures, we need to identify them as hazards early in the process of barrier design, because it can be quite a costly and time-consuming exercise to design and install a barrier on something like this. There's limited depth for posts, so we're looking typically at bolt-down post arrangements that might require a concrete footing to be structurally designed, a ground beam perhaps with a pile at either side. So I stress to you, be mindful of structures and start thinking early on how these sort of hazards are to be addressed. Fill batters can be hazards or not, and there is some guidance in the updated Guide to Road Design Part 6 around this. It differs somewhat from previous guidance. We talk about recoverable batters, drivable batters, traversable batters. The particular change that I want to point out is that previous editions have referred to slopes between, this is fill slopes, so slopes sloping down from the edge of the road. Previously, slopes with grades between 3:1 and 4:1 have been considered traversable and therefore non-hazardous. The change that I want to point out is that any slope steeper than 4:1 is now considered a hazard in its own right. That's stated in Guide to Road Design Part 6. It somewhat contradicts some other guidance in the Austroads suite of guides, such as in Part 3, which still refers to 3:1 batters as being traversable. Flatter batters, such as 6:1, are desirable because they are considered recoverable, meaning that an errant vehicle that passes onto that batter, if the driver is alert enough, they should be able to recover their vehicle and steer it back towards the road. Any fill batter, however, is likely to cause a vehicle to travel further from the road than it otherwise would. So hazards that may seem a long way from the road, perhaps a greater hazard than you might expect. Cut batters, as Ken mentioned, there is a school of thought that a nice smooth cut batter is effectively the same as a rigid barrier and that it will contain and redirect a vehicle in a relatively safe way. They are a subjective thing to assess. It's particularly the case where we have uneven surfaces that a cut batter presents a hazard. There is that rollover risk associated with a vehicle travelling up a cut batter and rolling over. A particular hazard is present where we have a table drain at the base of a cut batter. And you can see in the image at the bottom there, the combination of a low fill batter slope and then a cut batter. So where our grade change is quite abrupt, we can have vehicles snagging against the cut batter. And there is some guidance in Austroad's Guide to Road Design Part 3 around acceptable or preferred combinations of foreslopes and back slopes to avoid that situation. So cut batters really are to be assessed on a case-by-case basis. Where we're in cut, we're often in highly constrained environments. We don't have the luxury of a wide verge to install a barrier and provide deflection space between the barrier and the cut to provide a good and desirable shoulder width. There are lots of reasons why it can be undesirable to install a barrier in a cut situation. But on our high speed, high volume roads that are increasingly being retrofit with continuous barriers, the decision is generally made to install continuous barriers in front of cut batters, and that results in an improved safety outcome than leaving the batter exposed. This rural road was assessed. It had a high incidence of run-off road crashes. The entire length was assessed and isolated barriers were installed around the most significant hazards. This cut batter, due to its surface, is hazardous. It has a little drain at the base, which adds to the risk. But the decision on balance was made not to install a barrier here because installing one would have resulted in an overall safety disbenefit. It would have introduced a number of issues that were not present previously, including obstructing sight distance around the curve. It would have further compromised the shoulder width. Space for deflection was limited. So in this case, installing a barrier about this cut batter would have created a greater issue than it addressed. Further up the road, we had a relatively smooth looking batter. Again, it's on the inside of a curve. So if we were to install a barrier around this batter, we would have created a sight distance issue. We would have restricted our stopping sight distance available to the pavement or to an object on the pavement. In this case, we also have a curb present. Curbs often complicate the installation of barriers. They limit our options in terms of where the barrier can be placed laterally from the road. So lots of reasons here why installing a barrier was not a good idea. Of course, the Rolls-Royce treatment might be to cut the batter back further, create a nice wide verge and install a barrier. If we consider this location particularly hazardous for other reasons, but in terms of assessing the cut batter in its own right as a risk, this one was relatively minor.
Jamie, I might just jump in there and remind everybody that you are welcome to ask questions as we go through the Q&A. Just ticked over halfway through today's session, and I thought we might just give you a couple of minute break to have a stretch and fill up your coffee. And while we do that, I'm also going to put a little poll up. Now, this is a question on some content Jamie's already covered. You are not marked on this one, but this is kind of the style of question you will get in your quiz, which you will be marked on. So this one's just check that you're listening, but we don't know who's answering it, so it's anonymous. So, but just have a guess. So what I'll do is I'll launch that poll. Hopefully it will come up. It may not work on all your computers, but we'll pop that up, and I'll give you 3 minutes. And in that 3 minutes, you can have a stretch and have a little bit of a break, and also answer the question which Jamie's covered. And we will see you back in 3 minutes. 2 minutes and a bit now. So I can see quite a few of you have been able to see the poll, so that's good. And if you can't see it, the question is, at what height does a vertical drop, become a significant hazard? 1 meter, 1.5, 2, or 2.5? And this is according to the Off-Road's Guide to Road Design, Part 6. We'll give it another 30 seconds as people come back with their glass of water. Jamie, you're going to have about 50 minutes left, or maybe a little less if you need. And we will have opportunity for anybody to ask any questions as we go along. And so you can ask Jamie to jump back to another slide or elaborate on a different topic as we go. Okay, I'm just going to end that poll now, and I'll share the results because I'm pretty happy with that, Jamie. That looks like everybody's paying attention and understands that there's that 2 meter drop was the point in the significant hazard. And so that's an example of the type of or question that you'll be asked in your quizzes. Some of them are a little harder than that, but certainly it is stuff that is covered and you should be able to find. But yeah, 2 meter drop strikes me as quite high, Jamie, as a drop. Any comments on that?
Look, it is. Yeah, it is quite high, I suppose. If you're travelling at speed, it certainly wouldn't tickle. It's a drop that you would expect a vehicle to potentially nosedive off or roll. It's not one that the vehicle would continue along merrily on its way after crossing.
Yeah. And we do have a question that's come in from Wade. So recoverability has changed from 4 to 1 to 6 to 1 for light vehicles. Has the 6 to 1 for heavy vehicles changed?
Not that I'm aware, Wade. I'll have to take that on notice though and confirm that.
All right, back over to you, Jamie, to keep ticking along.
Thanks, Ken. So that they really are subjective things to assess cut batters, and they can be deceiving. This is one, and I should have the before photo, but it was a nice, relatively, or really quite flat, grassed cut batter, but it was soft and sufficiently soft that when the SUV struck it, it created a divot that was enough for the vehicle to snag and roll. So there certainly is benefit in general to shielding cut batters with safety barriers. Stepping down the list of seriousness of hazards, we have the category of less significant hazards. So these are ones with a lesser trauma index than those in the significant hazard category. They're hazards that might result in an injury, but generally not a serious or fatal one. But of course, it depends again on impact speeds and angles. So we have things like slip base or frangible poles, fill batters that are less severe, so lower and less steep than those in the significant category. Some hazards, such as rocks protruding a little above the ground surface, that would cause a vehicle and the occupants some significant discomfort, but not cause the vehicle to stop abruptly. Watercourses that are relatively shallow. What else have we got? Fill batters and so on. So these are the less significant hazards. Within that category of less significant hazard, we have the subset that is referred to as minor hazards. So these are some less severe fill batters again, some shallow watercourses, and so on. Now, it's important to note that impacts with any of these hazards, including minor hazards, are expected to be more severe than impacts with safety barriers. Now, this again is a significant shift from the philosophy that was adopted in the previous edition of the guide, which essentially said that a safety barrier should be considered a hazard in its own right, and that you should explore other options such as eliminating hazards, lessening hazards before you consider installing a safety barrier. The improvements in technology and barrier system technology that have happened in recent years have seen them become much safer, to the point where installing a safety barrier at the roadside will rarely result in a worse safety outcome. Now, we do need to be careful about certain things in terms of design, how we go about designing these things, lateral offsets, locating terminals, which are the most hazardous part of barriers in locations where they're least likely to be struck, and so on. And we'll talk more about those sort of things a little later and later in the week. So all of these hazards, the three categories that we've just discussed, appear in a table form in the guide, which is probably an easier way to compare the different types of hazards within those categories. So if you're thinking fill batters, you've got a particular fill batter slope and height. Which category does it fall into? Look to this table.
Jamie, just before we sort of finish off with cut batters, there's a question that's come in. Jamie, do you have any examples of a batter on the back of a curve where a barrier was installed with non-standard deflection and the reasons for why the barrier was installed?
Yeah, look, that has happened on numerous occasions on highways and freeways in Victoria, certainly. And it's often the case that post basins are reduced and every effort is made to limit the deflection of the system. But even still, it has been accepted on occasion that some of the expected deflection will occur within that cut slope area. And it's usually the case that only a small amount of that deflection will extend onto the cut batter, perhaps a few hundred mil or something like that. And if the cut batter slope is relatively gentle, perhaps 4 to 1 or something like that, I think the safety potential for an adverse safety outcome is pretty minimal. You need to be choosing your barrier system to limit its deflection and reducing post spacings to do the best that you can in those situations. Often the alternative is to undertake a huge amount of earthworks to gain a little bit more space. And that's just not viable a lot of the time.
Yep. And we'll talk a little bit more about things like reducing post spacing to reduce deflection and that as we tick along. But hopefully, Chantal, that's answered your question there.
Yeah, cut batters really are an interesting case where you have a cut batter. You typically have a curb, so that's in the mix as well, and you really do have limited space. So you need to do some careful thinking as to how you go about your barrier design. Hazards for motorcyclists and other vulnerable road users. I won't go into motorcyclists too much because Ken will talk to this in detail later in the week. But in a nutshell, some smaller diameter hazards that are not considered hazardous to motor vehicles certainly are to motorcyclists. So we're talking our standard sign supports, 50mm nominal bore, poles, for instance, what are considered frangible light poles are certainly not frangible for motorcyclists. Trees with diameters less than 100mm. So lots of things that are hazardous to motorcyclists that we just don't think of when we've got the blinkers on and are thinking cars and heavy vehicles. Locating these objects where they're least likely to be struck by motorcyclists is hugely important. There are certain areas that motorcyclists are notoriously leave the road, backs of curves, roundabout central islands, and these type of things. And there is a roundabout where we have lots of things going on that are potential hazards for motorcyclists. Perhaps some opportunity to relocate some signs slightly, or to use some sign supports that would be frangible to motorcyclists. And I'm thinking this hazard board within the roundabout that could be installed on some flexible posts perhaps. I'll leave it to Ken though to talk more about these type of things later in the week. Lateral distance to hazards. Previously we have, it's all been about clear zones, and I'm sure you've all heard that term. The clear zone was that nice clear area next to the road that we like to provide to reduce the likelihood of an errant vehicle striking a hazard. The typical clear zone in a high-speed environment was something in the order of 9 metres. We perhaps extended that up to 15 or thereabouts on high-speed, high-volume roads. In lower-speed environments, it might be as little as 3, something like that. The recent release of Part 6 has done away with clear zones essentially, or it's certainly recategorised them as what we refer to as a supporting treatment in safe system language. So a supporting treatment is one that reduces the likelihood of something happening, but certainly doesn't eliminate it. So clear zones fall into that category. If and when an errant vehicle travels beyond our clear width, there is still potential for a serious outcome involving a crash with an object or a rollover event, and so on. They do improve safety, but they certainly shouldn't be considered in their own right as enough when we're striving to achieve safe system outcomes. This image shows what might have in the past been considered an ideal roadside with nice clear areas within the median and at the outer verge, 9 metres plus, free of trees and any other hazards. This type of roadside still does present a rollover risk. It is very difficult to achieve a nice clear roadside throughout the year in all weather conditions that is smooth enough and well compacted enough to avoid a vehicle rollover. When we have vehicles yawing, roadsides that look nice and smooth and safe still do cause vehicles to roll. So that is certainly one of the key reasons why we're not thinking clear zones anymore. The other is that we know that vehicles travel well beyond the previously adopted widths. Clear zone widths were based on some really old research in the States dating back to the 60s, I believe. And they involved measurements of wheel tracks, errant vehicle wheel tracks in snow. So when you think about the changes in the vehicle fleet and the difference in conditions that we encounter in Australia compared to the origins of clear zone thinking, they really don't stack up anymore. Some more recent research has been undertaken, and actually quite a number of pieces of research have been undertaken around what sort of clear area would we like to provide or need to provide adjacent to our roads to achieve a safe system outcome, to avoid vehicles travelling beyond the old clear zones and striking hazards. And bear in mind that these widths would need to be well compacted and maintained throughout the year to avoid that rollover risk. So we're talking huge widths that just aren't feasible, that we wouldn't entertain providing in high-speed environments or in any situation. 50 metres or thereabouts is just not something that we would seek to do. So installing safety barriers is a much more attractive proposition. It actually allows us to reduce our footprints in a lot of locations, even steepen up batters, retain additional vegetation and all of these things, avoid impacts, avoid the need for land acquisition, and so on. This image comes from the new Guide to Road Design Part 6. You may have seen other similar versions previously, but it demonstrates the effect of fill batters on the distance that a vehicle will travel from the edge of the road. And it brings in some of these numbers that we discussed earlier, 6-to-1 or flatter being a recoverable batter, and one that generally would not cause a vehicle to travel further from the road than it otherwise would, or much further. Where we're sort of steeper than 6-to-1, we expect the vehicle to travel beyond the toe of that batter and potentially strike any hazard there. If that batter slope is steeper than 4-to-1, it's a hazard in its own right. We're not worried about the tree further away. The critical hazard is the batter, as it's likely to cause a vehicle to roll. One of the key additions to the new Part 6 is a risk assessment process for assessing roadside risk. So this basically replaces the old clear zone thinking. Obviously, it takes into account the offset of hazards from the edge of the road. So there's an element of clear zones in there, but it considers a number of other risk factors. And it uses this fairly sort of typical risk assessment process, considering exposure, likelihood, and severity of impacts. I won't go into a lot of detail on this, but I do encourage you to look at the new guide. And when it was released, or shortly thereafter, Austroads put out 2 webinars to explain this process in particular. I assume they're still available at the Austroads website, and I encourage you to look at those, and particularly the first webinar of the 2. The second is more about the background research that went into developing this process. So I'd like to give you a bit of a snapshot, but I encourage you to also look to the webinar at the Austroads website. So it has this risk assessment methodology, and it uses this term network roadside risk intervention threshold, which is a bit of a mouthful. And it basically, that NRRIT sets a level at which we might want to intervene and take steps such as installing safety barriers. and each jurisdiction is currently doing some work to come up with some guidance around this and at what level we might entertain taking certain steps. There's the risk assessment process in a diagrammatic form. We're really talking about the bottom part of this process, which is about coming up with a risk score for your particular section of road that you're interested in, comparing that score with an NRRIT that's determined by the relevant road authority, thinking about treatment options and prioritising the highest risk sites and then implementing those treatments. The guide talks about hazards being background or isolated hazards. And it's often the case on a particular piece of road that we have both. The background hazards are consistent and continuous. So it might be a continuous row of trees. It might be a batter. It might be a cut batter, or perhaps the hinge point to a non-drivable fill batter. It might be the fence at the property boundary, or it might even be your clear roadside, which has its own inherent risk. There are typically also isolated hazards within the roadside. So they're the occasional tree or pole or other rigid object or watercourse or whatever it might be. So hazards located fairly close together are your background hazards. What else have we got? Yeah, so the assumption is that a vehicle that manages to pierce through those isolated hazards will strike or reach the background hazard. So keep those two terms in mind. You can see on this road, you could probably argue that there are some isolated trees, a few meters or so from the edge of the road. There's one, perhaps some more there. But nearer to the property boundary, there's a more consistent line of trees, which might be considered your background hazard. In a built-up environment, your property boundary fence, this bricked fence certainly is a hazard. So that's your background hazard. And we have the odd isolated hazard in front of a tree here, signal poles, more trees. The guide provides a series of charts, and there's something in the order of 20 or 30 of these. There's a different chart for each combination of rural or urban location, the terrain type. It talks about mountainous, rolling, or flat terrain. The different charts for different operating speeds, 70, 90, and 110 kilometers per hour. So lots of different charts. You need to locate the one that best suits the site that you're looking at. You can then look at your traffic volume, your offset to your hazard, whether it's a background hazard or an isolated hazard. You'll notice in the title here, this one's about background hazards. You then need to read up the relevant chart from your AADT to your hazard offset, and then across to the vertical axis to identify a risk score for that particular road or section of road. You can interpolate between the lines if you have hazards at different offsets to the numbers identified here. For any particular road, you can break it up into as many sections as you like and identify the variation in risk along a road, and therefore the sections of that road that might be considered a higher priority to treat. It gives a method for, or a means for comparing different roads and identifying or prioritising sections of road for treatment.
Jamie,
yes.
I'm sorry, Jamie. A question's come in from Mark. G'day, Mark. Have any other jurisdictions set NRRIT to target any of their program funding yet? In New South Wales, they're just starting to investigate and noting that the guidance is quite new. So
none that I'm aware of, Mark. Vic Roads is fairly well progressed, but have not published anything. So we can, well, actually, great question for Evan Coulson tomorrow. He's heavily involved in that. He'll be able to tell you the status of the Vic Roads guidance, but none that I'm aware of that have released anything yet.
Yeah, no, that's the same as I was going to say. I don't think anybody's quite there yet. There's a bit of work bubbling away in the background in a number of jurisdictions, but certainly these risk graphs can be useful for understanding relative risks and the like. So they're not useless unless you have an NRRIT score or a threshold that you're working to. But yeah, it's something that I think all jurisdictions are going to have to get their head around.
I noticed another question is coming from Wade, and it's one that I've wrestled with many times. Wade's asked, has the change of thinking about clear zones affect the length of need of barriers, such as on the approach to a hazard such as a watercourse? So where we're looking to shield a watercourse that continues a long way from the road that is crossing it, we need to adopt a width, a protected width, to determine our length of need for our barrier. And commonly that width would have been our clear zone. So it's a great question, and one that I don't have a good answer for, I'm afraid. We need to draw a line somewhere. You might base your barrier length on a clear zone, or perhaps the width to the property boundary, but you need to make a call on a width. So good question. So here we have some more charts from the guide. These are ones where there are no isolated hazards in an urban environment. So you can see that the numbers on the vertical axis are less than we saw in the previous charts, because our speeds are lower essentially. This is quoted directly from the guide, which outlines some treatment options when we have identified hazards. Now, this is a shift from the previous guide, which had a hierarchy of treatment, and installing barriers was basically at the bottom of the list. It was preferred to remove hazards, to treat them in some way, relocate them, and then think about barriers, on the assumption that installing a barrier or introducing a barrier to the roadside was introducing a hazard, essentially, a risk to the roadside. And that if we could avoid doing that, we should. That's not the case anymore. Now, this list isn't in priority order, although installing barriers is at the top of the list, and I suggest in many situations should be. Certainly in high-speed environments, installing barriers is the way to go. There are things around designing that we need to be mindful of to minimise the potential for harm, which can be associated with locating barriers too close to roadways, impacts with terminals, which, although they are tested to certain levels, are the most hazardous parts of the system and can cause injury to vehicle occupants. Some more quotes from the guide. Primary method of mitigating risk due to vehicles leaving travel lanes is to install safety barriers. Again, that is certainly the case in high-speed environments. In lower speed environments, where our speeds are within those safe system thresholds of perhaps 70 and 50 kilometres per hour, depending on the crash type that we're talking about, we wouldn't entertain putting barriers in, certainly in 50-kilometre environment, for instance. It does recognise that we need to consider the risk associated with installing a barrier, and that one should only be installed if it reduces that risk. But in most situations, the barrier will reduce that risk. We need to recognise that a barrier will be struck more often than the hazard that it's intended to shield, because that hazard is located further away. It is often the case that an errant motorist will be able to recover their vehicle and get back on the road before striking that hazard. So barriers are subject to many nuisance impacts. Not every impact is a life-saving one. However, some of them are. And any impact, or the vast majority of impacts with barriers, are result in little or no injury to the occupants of those errant vehicles, particularly when we're dealing with flexible barriers, which are our preference. As I mentioned, terminals of barriers are the most hazardous part, especially where we're dealing with barrier products that are no longer accepted for use, and often for good reason. We know that some of the older products, breakaway cable type terminals, present a spearing hazard to vehicles. So these sort of systems should be replaced wherever possible, wherever funds permit, or wherever they're impacted on site. They should be replaced with a currently accepted impact absorbing type terminal. We need to be mindful of where we locate terminals in particular. We don't want to locate them on the outside of curves, within curves, for instance, where we know that vehicles are prone to leaving the road. We should flare them away from the road, even by a small amount wherever possible, to minimise nuisance impacts. A similar situation that occurred recently, where the terminal, again a breakaway cable type terminal, didn't, fortunately in this case, didn't spear the vehicle, but quite easily could have. Hopefully the occupant of that vehicle, walked away. But these terminals, their entire length is ineffective in redirecting a vehicle, so there's that risk associated with the end-on impact and potential for spearing. They also provide a reduced effective length, so there's lots of reasons why the newer breed of products are better than these type of things. This is not an accepted terminal product, and it is one that could quite easily spear into an impacting vehicle. Fortunately, our speeds are relatively low at this location, so the risk is probably low, but any product installed at the roadside should be a currently approved product. Refer to the RMS website for the list of those. I'm not sure exactly what this barrier is doing. It's certainly not shielding the pole that you can see there. It looks to me to be more of a device to funnel pedestrians than anything else.
Jamie, we'll just pause there for a question that's come in. Is there consideration for the increased risk to maintenance workers and broken down vehicles not being able to fully and safely pull off the road if the distance between edge line and barrier is 2.5 metres or less? And I think you covered this a little bit on Wednesday, but any initial comments?
Yeah, no, absolutely. We'll talk about this in detail on Wednesday, but it is a significant consideration, for maintenance reasons and the safety of people that need to pull over at the roadside. There are desirable offsets that we like to provide to allow a vehicle to pull over clear of traffic. We'll discuss those. So the desirable thing is to allow a vehicle to pull over clear of traffic, open the door, change a tyre, all of these things. It's often the case that we don't have the luxury of the space to do that, and we do install barriers closer than that. Where we do that, we need to think about the risk of doing so, and take steps to mitigate those risks. So we might look at providing refuge bays and encourage motorists to use those if and when they have to pull over. There are offsets that are non-preferred, that are sort of in that sort of 2.5 metre range, that might appear to a motorist to be enough for them to safely pull over, but are not. So, it can be argued that an offset of perhaps 1.5 metres is a safer one than a 2.5 metre offset, provided that you're flaring your approach terminals and doing all the right things. But it really is dependent. It's a case-by-case decision. If it's a short length of isolated barrier, that an offset of something like 2 or 2.5 metres, and there are plenty of opportunities either side for someone to pull over clear of traffic, and we're flaring away that terminal to reduce nuisance impacts and shoreline effects and all of these things, then it's no big deal. But if it's a long, continuous length of barrier at a 2.5 metre offset, something like that, that's a bad idea.
All right, and we'll definitely continue that discussion on Wednesday when Jamie gets into the details of barrier design and making those choices on offset lengths, breaks, and all of those specific things. But it's certainly a topic of interest to quite a number of people across Australia and New Zealand, and something very important that we get our head around and have some good processes and decision making, or ways to make decisions. So thank you. Let's keep ticking along, Jamie.
Yeah, so a couple of issues there that we've discussed. Non-approved end terminal, and not actually shielding the hazard. And I suspect that that's not why this was put in. And sometimes safety barriers do have, there are ulterior motives behind installing safety barriers, but this is not ideal. The presence of the curb there, there's some design elements that are not good. This is a road east of Melbourne that has been progressively upgraded in recent years, and that Safe System Solutions has had it's actually generated a lot of work for us, assessing some problem locations on this road. It's a road, like many others, where there's been pressures to minimise the footprint of the road, and it's resulted in some really narrow flush central medians. We're talking 1.4 metres, and some guard fence has been used in the median in a lot of places, which has this particularly wide terminal. So there's a very limited offset to that terminal from either side, and the traffic lanes on either side. And very shortly after that terminal was installed, the Coles truck there took it out. And there have been a lot of impacts with terminals along this road, particularly by trucks, which generate a lot more sway. And most of the impacts along the continuous central barrier have been with terminals, and trucks have certainly been overrepresented. There have been a lot of learnings that have come out of how this has been gone about in Victoria. Certainly the median width has been reconsidered, and where some guidance has come in to increase that median width, or at least locally increase it at terminal locations, and desirably install a raised island with enhanced delineation before the terminals to avoid this situation. Another location where a wire rope had just gone in and it was still under traffic management with a reduced speed limit as well, but it was taken out presumably by a truck just based on the length of damage, which was huge. So the message is that these exposed median terminals need a particularly high level of delineation. They do present a hazard, both from the initial impact, especially if it's a passenger vehicle or even a motorcycle. There is potential for injury. There's also that potential secondary consequence There have been cases of trucks striking them and catching fire, roads being obstructed and closed as a result of impacts. So be mindful that what you might have considered a nice, safe roadside, a flat, clear zone next to the road, is not a roadside that meets safe system objectives. Rollover crashes can and do occur. Vehicles travel well beyond the clear zone lengths that we might have had in mind previously. And these roadsides, they present a risk. And on a high speed, high volume road, there is certainly a benefit in installing continuous barriers. It's certainly justifiable in terms of benefit cost analysis. And I encourage you not to think clear zones. Refer to the new Part 6 for some updated guidance, which hopefully takes some of the subjectivity around assessing certain hazards. And stay tuned for some guidance from Transport for New South Wales around NRRTs. That's all from me, Ken.
Thanks, Jamie. I was just fumbling around trying to find my unmute button, but all good. All right, so if you stop sharing your slides there, Jamie, and we'll see if anybody has any questions, and feel free to raise your hand if you just want to talk your question at this stage, and we'll allow you to unmute yourself. But also feel free to put it in the Q&A. So I'll give people a minute to have a think about anything they want to discuss at this stage, while I just run through a few points before we close off today's session. And there's a bit of terminology that Jamie's used, which is sort of run-of-the-mill in the road safety barrier industry, designing or maintaining the like, that may have thrown you. You may not quite know what he was talking about. Now, Jamie, am I right in saying that there is a terminology sheet that we can provide?
Yeah, absolutely. It's about 3 or 4 or 5 pages of terminology and some diagrams illustrating some of the key terms around barrier layouts, particularly, that is in the Austroads guide, and we can easily provide a copy of that.
Yeah, so what I'll do is we will put that into Moodle in the resource folder in Moodle. So it's something there that you can access. There's a few things you mentioned there. Shy line as one that I thought, oh, that's very much a barrier term that people may not know. Now, that being said, Jamie's going to explain it again on Wednesday and how it works. So you'll get most of it, but it's a nice little reference sheet as people talk about some of these things. So we'll make that available in Moodle. I suppose one of the things, my takes on this intense desire to roll out barriers compared to sort of just relying on a bit of clear zone, has really come about because of the increase in barrier technology, the advancements in barrier technology. The fact that barriers really now are incredibly well designed, tested, and we can have quite a bit of confidence that the barrier performs well and doesn't present that increased risk. So probably 10 years ago, 15 years ago, we really wouldn't be right to be thinking this way, but there's been that wonderful advancement. So more often than not, we do sort of tend towards a barrier if we can afford it, if it can fit, if it's got the right design characteristics. But we're fairly confident the safety outcomes for passenger vehicles, and then there's some benefits for other vehicles as well. What are we getting? Mitch has got a question here. Common question is, well, we use guardrail in some locations and wire rope in others. Keen to get your thoughts on this, and what would you consider the best option? Jamie, do you want to start with that one? And again, another one where we'll be talking quite a bit about choice of system, but Jamie, you can have an initial start.
Yeah, and it depends on what we mean by guardrail. There's a range of products available now, flexible guardrail systems. I assume you're probably referring to um, the public domain, semi-rigid guard fence, G4 and the like, which is no longer accepted for use. It's a legacy product. It's a semi-rigid product, so it's less forgiving on your vehicle occupants. So that's its downside. It doesn't deflect by as much, however. So guard fence products typically have an advantage over wire ropes because they don't deflect by as much. So if you're constrained, it can be an attractive option. Wire ropes are the most flexible systems we have and therefore the safest. So from that point of view, should be preferred. But the newer flexible guard fence systems are not far behind in terms of flexibility and safety. So they're typically bundled in the same category of flexible barrier. And yeah, it's pretty marginal, the difference in terms of safety.
Yeah, I'd agree with that. And certainly I say there's a sort of a science and a bit of an art to the barrier design. And you'll see that where you want to understand the products, how they function, what their expected safety benefits are, and all the constraints in designing and choosing and maintaining, and how they impact on different road users. And you factor all of that mix in, and then off you go. But the more flexible the barrier in general, the better the safety outcome in most scenarios. So it's worth starting at that and then working your way down and then altering your barrier if you can't fit it or the like. But it is very much case by case dependent. But we will delve a lot more into that because it's a very good question. Now, we've got another question that's coming from Chantel. Jamie, why don't you read that as a bit there, and I'll cover off a few more things while you get your head around that. If there are topics that anybody out there wants covered, you're welcome to just email me those or the like, and I'll just make sure we are going to cover them. And if we're not, we'll allocate some time to that. And most of the things you're bringing up are great questions, and they come up quite a bit in different jurisdictions where we run the technical training, and so we do go through these in a bit of detail, but certainly it's worth checking that. Also, later in the week, we have allocated some time to do some live discussion about any topics, sites, design issues, maintenance issues you have. So if you have a location that's particularly challenging in terms of barrier design, or you've got a barrier out there, you don't know what to do with it or the like, feel free to send those through to myself at any point. And what we'll do is jump in there in Street View or look at photos you've got, or the design. We'll bring the design up and we'll get Jamie and Evan and others to have a look at that and make some commentary live. It's a great way to learn. So you've got an option there for some individual project advice, which we get some good learning out of. So have a think about that if you've got anything in particular, and send through the location or some photos. Now, Jamie, did you have a read of that one?
Yeah, Chantel mentions a project where the decision has been made to maintain some wide clear areas next to the road, and that's because it's a road with relatively low volumes and it's been progressively upgraded. So, yeah, look, we're installing continuous barriers sort of on our highest risk roads, our divided highways and freeways, which have particularly high volumes, and that's sort of gradually filtering down through the road hierarchy. Where we've got low volumes like that, there isn't, you can't demonstrate the cost benefit of installing continuous barriers. So look, what you're doing sounds like a cost-effective way of providing a good level of safety.
Yeah, and that's right. I mean, barriers are expensive, and the extent of the road network in New South Wales is huge. So the idea of continuous barriers on all the country roads in New South Wales is not feasible with the dollars we have available. So a way of managing, prioritising, and then treating other roads with other treatments is really the only option. And And the Centre for Road Safety is doing some good strategic statewide thinking in that space, and that's really good stuff. We are going to, I suppose, as we tick along through this course, drill more down into the individual project and barrier decisions and design and choices rather than that sort of statewide strategic choice making. But it's certainly a very good question with a good topic. So thanks, Chantal. Okay. Well, a few other things from me before we close out today's session. So in Moodle, you have a quiz to do. It's 10 questions, and the easiest thing to do is do it straight after this. Now, you might have a meeting or something to go to, but it'd be good to get to it. In theory, just to the end of the course, you can do them whenever you want, but the best way is to do it straight after the session. It's fresh in your mind and you get it ticked off. Tomorrow's session with Evan Coulson starts again at 9 o'clock, and log in a little bit early for a chance to win a prize with the trivia. Evan will be going into some details about those barrier types that we started talking about there, and what they are expected to be able to do and not do, and how they've been tested. The notes will, the recording will be available to you. We'll put a link to that in Moodle when that comes through, the recording. And the notes are available in Moodle and on a memory stick if the memory stick arrived for you. I just do note that the actual PDF on the memory stick is for the few slides, overview slides I showed, is not the correct one. The correct one is in Moodle though, so you can use that. That was just setting the general scene for the scale of the issue we're dealing with. I think that's about it. Jamie, anything final to add from you?
No.
Okay, so we'll see Jamie again on Wednesday morning, where he'll delve into barrier design and start showing you how to calculate some different lengths of barrier required and do other exciting things like that. Tomorrow you've got Evan Coulson and myself, and we'll start again at about 8:57 or something for a chance to win a prize. So thank you very much. Jump into Moodle, do that quiz, and introduce yourself if you haven't done so already. But otherwise, have a good day.